Let's start with a number. 400 miles. That's how far you'd have to travel straight down deep into the Earth's interior to find a reservoir of water larger than all of our planet's oceans combined. It's a discovery that forces us to rethink what our planet actually is. Because in many ways, it means Earth is a giant sponge. You see, back in 2014, scientists were able to confirm something truly mind-bending, that deep within the Earth's mantle, there are these huge stores of water. But it's not liquid. It's trapped inside a solid blue mineral. Now, to be perfectly clear, we're not talking about some vast underground sea that you could, sail a submarine through. This water exists as individual molecular particles, and they're locked right into the crystal structure of solid rock. The concept, when you boil it down, is as simple as it is profound. It's just water bonded directly to crystal. And the mineral responsible for this amazing feat is called Ringwoodite. It basically acts like a planetary storage tank, and it could be holding up to 3 times the 1.3 sextillion liters of water we have on the surface. So how can an entire ocean exist so deep inside the Earth? Well, that brings us to our first section, a subterranean ocean. It all comes down to pressure. The pressure in the mantle is hundreds of times greater than what we feel from our atmosphere. And it's this immense force that literally shoves water molecules into a crystalline cage, creating what is essentially a high-pressure mineral trap. We know this because scientists have confirmed it in labs. This bright blue mineral, ringwoodite, can only form between 410 and 660 kilometers deep. Down there, the environment is just a crushing oven of unimaginable heat and pressure. Okay, so let's get a better handle on how this mineral actually pulls this off. Section 2, the crystalline sponge. Ringwoodite is incredibly strong, and it stays stable even under the mantle's intense heat. Think of it like a cosmic hard drive for hydrogen. In essence, it really does function like a stone sponge. And here's the really wild part. Even if only 1% of the weight of the mantle's transition zone is water, that tiny 1% fraction still outweighs all the surface oceans by a factor of 3. This deep water has probably been down there since the very birth of our planet. Now, we know some of our surface water arrived on icy comets, sure, but it turns out a huge amount of it was already here, baked into the primordial minerals that formed the Earth 4.5 billion years ago. But here's the thing, this deep water isn't just sitting there locked away forever. It's actually part of a massive, slow-moving cycle. Which brings us to section 3, a planetary heartbeat. Our planet isn't some static vault. This water is part of a slow, multi-million-year circulation between the surface and the deep interior, a planetary-scale heartbeat. A raindrop falling on your head today might eventually travel hundreds of miles down, only to be released millions of years from now as volcanic steam. And this isn't just a theory. We can see it in action. Beneath East Africa, these hidden water reservoirs are so concentrated that they're influencing the literal breakup of the continent, helping to accelerate a 2,200-mile-long crack in the Earth's crust. What happens is these mineral-locked water supplies interact with rising streams of hot rock, and that weakens the lithosphere above. The effect is, well, it's profound. It is, quite literally, water tearing land apart. So what if all this water came to the surface at once? The global sea level would rise by several kilometers. Even mountains would be drowned. Thankfully, it's all locked away by gravity. The extreme pressure at those depths makes sure the water stays trapped in its solid mineral form. Research suggests this ringwoodite isn't spread evenly either. Some parts of the mantle are like these vast, damp basins, and that creates unique, geologically active spots, just like the East African Rift, where the planet's internal plumbing is on full display. The implications of this discovery, though, they go far beyond just the geology of our own planet. This is Section 4, a new blueprint for life. Finding this internal ocean really does change everything. It changes how we look at every other rocky planet, not just in our solar system, but everywhere. What this discovery has given us is effectively a brand new blueprint for finding life somewhere else. Think about it. It suggests that any rocky world with a mantle could be hiding its own secret water supply, deep underground, even if its surface looks completely barren and dry.